Hey guys, it's Will from Tested.
And it's Norm from Tested.
Norm, it is Friday. This has been a big week.
Time for a print of a mystery object.
Well, first,
we need to get a 3D printer working.
First, we have to do our first print. We have to calibrate stuff. We have to get the software. This uses all new software that I've never used before. So, maybe?
Maybe.
Maybe.
So here's what we're doing today.
Yeah.
We spent this entire week building the Printrbot.
It's not been all week.
Well, you've spent this entire week watching us build the Printrbot, which is a $550 3D printer, and we finally assembled it. We haven't set it up yet to print.
Nope.
That's what we're going to do today. This is a video sponsored by Tested Premium members, subscribers on Tested. We're doing a whole month of building.
So the first things first. You've probably never seen me do this before, even if you've watched every MakerBot mystery object we've ever done. But I got to put tape on the build surface.
All right. So explain the tape. Why is that's painter's tape?
This is blue painter's tape. It is 3M 2080EL. It is slightly more expensive than the generic 3M painter's tape.
You mean the small one with the narrow, cheap ones?
Well, so painter's tape is priced on both the width of the tape as well as the relative stickiness. So with painter's tape, since this is going to go on, you want less sticky. That's better. And what we do with this is just put it over the build platform, and I'm going to tear the. Oh, hellfire!
There it goes.
Okay, there we go. This is hard to do from this angle, also.
Okay.
This is not super sticky. But you kind of want to get no bubbles, and I just do a rundown. Usually I use what's called the Kapton tape, which you may remember from the space program, among other places. It is space age technology, and what this does is it gives a better surface for the print to adhere to.
Why is the surface, this material of the tape, good for this plastic to stick to? This
you use mainly because it's cheap, and it makes it a little easier.
What about this is better than just
using the metal? The reason you don't just use the metal is if you crash the print head into the metal, then you can damage the print head, the nozzle, as well as scar up the print bed, both of which are bad for the quality of your prints after that point.
So it's a very, very it's soft.
It's basically a thin layer of protection to prevent you from doing something super dumb. And also it makes it easier, like with a heated build platform like our MakerBot Replicator 1 has, you can vary the temperature of the build platform to help release the print. The prints get really sticky, so all I'm doing here is just lining up with the edge so that there's no overlap, and it's even okay if there's a little bit of a gap, and then I'm pressing down. It's super exciting stuff. But we wanted to show everything, so here you go. I think I got maybe one more piece.
Now,
I might get you to do the one.
How often do you have to replace this tape?
It really depends on how often you gouge up the tape.
Oh, you've left some gaps.
That's okay. A little bit of a gap's not a problem.
All right.
You want to minimize those gaps as much as you can. Yep. I'll probably go back and redo this after if we use this for any mystery objects in the future.
And you also don't want to overlap.
You definitely don't want to overlap, because what you're talking about is a printer that can print in 100 micron increments. So 100 microns is about the thickness of a business card, like a good piece of cardstock or a decent sized piece of paper. You're not going to get, if you have overlaps, the print head will crash into those places that the overlap runs if you have the setup properly.
That's pretty good here. Gap I got there.
Did you nail it?
No gap.
Nice job. Never forget the gap. So the first thing we're going to do is get the height on. We got two things over here. This guy on the left, the metal thing with the orange tip, is the auto leveling probe, and it's a contactless probe, so it has a sensor that detects metal when it gets close to it. That'll trigger. There's a light on the top that'll go off. And the way you do this is you set it up so that this triggers when the print head is just touching the surface of the print
height
bed.
of these two things.
Yeah, and there is somewhere here, there's a little square piece of Delrin that's the right thickness. Is it underneath the printer?
Square piece of Delrin.
Oh, here it is. I moved it. That is more or less the height that you want the sensor off of the print bed.
That's good, so you can calibrate.
Sorry, I moved the printer, and now Joey has to run in here and change stuff. So I'm going to run this down just using my hand to turn the axis. And we're going to run it down until just when it touches. Now, figuring out just when it touches is surprisingly difficult.
Oh boy. Oh, you're gonna get the extruder hit before you get the.
You want that? We want that.
Extruder is just.
See, you can't tell because there's a shadow.
Do we need a business card?
A business card's not what we want. We want it actually touching. So we need something thinner than a business card. How about a piece? Can you cut one layer of that? And we'll slide that under there to see. The problem is there's always a shadow, so it's really tough to tell. I'm going to reach down here and grab a flashlight and see if that helps. Also, I'm right on a tape border, which is not good. I think that actually is looking. That's looking.
I can still move this.
Does it still move?
So what I'm doing is
So you don't want to push down on the print bed at all. Is that moving still?
Yep, still moving. Oh, nope. Okay, so a little looser than that. Okay.
So that I think that's pretty much it. I'll go back down just.
Oh, no.
Can't get under now. Okay, that's good. So now what we're going to do is use these two kind of crappy wooden wrenches to move the sensor down.
Which one? Those two nuts.
And one of them's already. Let's see. I think we need to go up on this one and up on this one, right? Yeah. Actually, this is a good time to turn it on. So would you plug it in, because we want to see that light trigger, and we want it to trigger.
All right. So I got power right here. I'm just going to plug it in the bottom. There.
Basic
Is there a power button at all?
No power button. If it's plugged in, it's on, and it's on.
All right. It is plugged in. Power supply right here.
Let me switch over and see if my software detects it. Unknown printer firmware disconnected. I'm not going to connect yet because I don't want it to do anything.
But it has detected it, which means it's on. There are no lights on this thing. No feedback whatsoever, except for.
Okay, I am going to go to connect and go ahead and do it. Okay, so Joe, if you want to switch over to the computer, this is Repetier or Repetier host. It's the Mac version of it, obviously. And basically what we're seeing is an emulation of our print area here. This is all the controls. This is a much more kind of raw version of the software than we're accustomed to with Makerware. It's very reminiscent of Replicator G. Oh, and I'm hooked up to a virtual printer because I was noodling the other day. So let's go. I'm going to disconnect.
Do you need me to tighten and loosen these?
No, leave it for right now. We're going to do USB modem 1, 2, 3, 4. Hit apply. Hit OK, and we're going to connect.
Okay.
Okay, so you can see on the bottom there it says firmware Marlin V1 Sprinter GRB matchup for Gen 6 firmware.
Nice.
Printrbot protocol version 1.0 machine type Printrbot extruder count 3. That's probably not right, but we'll get there.
Extruder count 1.
Extruder count is 1, but it knows that Marlin, which is the open source project that builds the firmware for this particular printer, among a bunch of others, including I think for the Makerbot, or Sailfish is the version of Marlin for the Makerbot. But we have, let's see, extruder temperatures down here. I can do some stuff, so I'm going to go back. I've connected. We've done that. I'm going to go to the print panel and give the following commands in this order.
Okay.
I'm going to give you.
I will read them out.
This laptop, so you can.
Very NASA.
Or this iPad, so that we can do this. See, this is a Chrome window. I'm going to Chrome this onto another device. It's my favorite feature of Chrome. There you go.
Okay. All right.
So we're on step 3.
Step 3.
Heat on. I'm going to the print panel.
And give the following commands.
Heat on. Okay.
Home X.
Home X.
Oh boy.
Something happened.
Yep. X has now moved to its home.
Okay.
So okay. Now hit home Y. Whoa. Okay. That's the Y-axis. Now we. Oh. Whoa. Stop. Let me know if I need to pull power at any time.
I don't think our Y-axis is tripping.
So these are the switches.
Yeah, let's go.
Should we turn off the power?
No.
Because you can, from this program, if you go back to the computer screen, you can manually adjust the Y-axis.
I'm doing that right now.
So yeah, as you tap, it goes move 100 spaces.
Yeah. Okay, 100 spaces.
Okay.
I'm going to hit the button.
All right. Is that stop? Is that triggering anything?
No, I don't think so.
So that tells us that that's not plugged properly into the board.
I wonder if, but the x-axis did go right?
I'm not 100% sure because it doesn't look like it's centered on the x-axis either.
It shouldn't be centered. It should be. Okay. Okay, so I'm gonna hit home.
Whoop, whoop, whoop. Okay.
Yeah, no, that is right. I'm pretty sure.
Okay. It's a robot. You're telling it to do things.
It is. I control the robot. I control the horizontal and the vertical.
Well, you're controlling the horizontal and the other horizontal.
Okay, let's see. I'm going to turn on acknowledgements. Nope, that's not a good thing. That's too much. Let's see if I can see
if the trigger is working.
Yeah, I want to see if there's. Let's see. That's G-code. That's slicer. I can't see if the print. I'm going to try it again and see what happens.
Oh boy! Oh boy! Oh boy!
Nope. Stop motor. Where's the stop motor button? Okay, there it is. It stopped eventually. It's.
Where's the trigger? Actually, where's the physical trigger?
We need to tighten that.
Oh, tighten. Yeah.
I did a pass on tightening, but this is real. This is weird. If you want to tighten those, cinch them down a little bit more.
You feel that? Okay.
It's still way loose. Just keep going.
That's super loose. It's much looser than before.
Yeah, I think you're about to get as tight as you can get, so we might have to take that apart and redo those zip ties.
Yeah, I am totally. Yep, this is the tightest as it can get. See? That is way too tight. Or way too loose.
Way too loose. Okay, so let's unscrew that.
Okay,
go ahead and unscrew that.
That's a relatively easy fix.
I'm going to start working. Let's unplug it first.
Okay.
Let's check the y-axis switch to make sure I did actually plug it in and it's plugged in the right place and all that jazz.
And this one I can just unplug.
Yep.
All right.
I'm going to put this down on its side.
It's okay.
Okay, so this. Okay, so that should be the y-axis stop right here.
Wow.
Which
this is really, really loose.
Wow, I shouldn't have put all these wires in like this. Okay.
Troubleshooting.
Okay, I have the Y and Z stops backwards. That's the problem.
Oh. Well, regardless, we still need to make this tighter.
Yes, that needs to be fixed.
That's not that difficult.
And again, this is like they didn't tell us which axis was the X and the Y axis. I mean, it's the kind
diagram.
of thing. Yeah, it's the kind of thing you should have known, I guess.
For the
just in general
control board.
But yeah, the board's labeled, but we don't know which axis on the machine is the X and Y axis.
Now, my question, Will, is
you're gonna have to cut that off.
Yeah, you need.
Let me give you the scissors.
Snips. Oh,
I'll do
cut them because we don't have snips and.
So,
it's all right. You can just cut them.
Yeah. Here you go. The trick to cutting snips is to get the outside edge. I can't get it from where I'm sitting. There we go.
And just pop off the top.
We're not wearing safety goggles, Norm.
I'm holding my glasses real tight to my eyes.
Okay, that's good.
Pop it. Pop it.
These scissors are not super sharp. Hey, remember that time I cut my finger off while we were building a 3D printer? I don't want to.
Oh, boy, hit my face. Ow.
Really?
Ow,
Did it really
hit right there. Yes, it hit my face.
Jesus.
My eyes
are you okay?
Okay.
Okay, so what we're going to do...
Tighten first.
I'm going to get it... Hold on. Let's get it up so we can see what's going on here.
Yep.
Now that is reasonably tight. I'm going to go one notch further.
I want to put this through these first.
So we see how far we have to work with. Yeah, that looks pretty good. My hands are smack dab in the middle of the way. I apologize.
You can put a little bit in there. No, I say put that in last.
No way, dude.
Plug.
We can't pull it tight enough.
We can. This is the loose you can get.
This is the mistake we made last time. I'm gonna show you.
So you're gonna tighten first?
I'm gonna tighten first, and we're gonna tighten right up at the dongle. So I'm gonna do this. Shit. Sorry.
Small zip ties.
How did you do this with one hand? That's impressive. Okay, so what I'm going to do is pinch this down.
I'm going to pull.
Yeah, but first let me make sure we're good distance. Okay, I can close that gap.
Okay.
Actually, I'm going to give it a little bit more. A couple of cogs worth.
Okay. I'm getting ready to pull for all I'm worth.
That's not enough.
Nope.
Don't pull for all you're worth. I just need you to keep it taut. That looks pretty good. Okay, so I'm pulling it pretty tight, and you need to get that super tight right up against the edge of the thing. It doesn't have to be in there. Okay. That looks pretty good.
It's biting?
Yeah, it's definitely biting. Okay. I'm going to cut the tip off.
We can tighten it more by just pushing it back. All right, too late now.
No. You can't push it back. It's a zip tie.
But you can kind of crank it.
Ratchet, you mean?
Ratchet it.
I don't think it needs to go any tighter because the thing you don't want to do is squeeze that belt so that you lose the tension on it. Where's the driver?
Yep.
Let's cinch this down just a little bit, and we can plug her back in.
Oh, it's much better. Much better on this side at least. Maybe it needs to be tighter on this side.
Well, it's all one belt. So as soon as you move, as soon as you ride the carriage along, it should be the same tautness on both sides.
Okay, that's pretty good.
My level looks pretty good.
You want to try sliding?
Yeah.
That's pretty good.
Well, that moves nicely.
Okay.
Moves much better. Okay,
right,
so let's get everything. Hold on. There's shit underneath it. There's stuff underneath it.
I'm going to plug this in.
Yep. Okay, we're still plugged into USB.
Power is on.
Yep.
Okay.
Disconnect.
All right.
Power's on.
Yep. Power's on.
I'm hitting connect. Okay, so now I'm going to home the x-axis.
Again.
Oh,
Jesus.
Nope.
Oh, Jesus. Oh, Jesus.
Okay, stopping.
Stop it.
Stop.
That looks like the y-axis. Or z-axis.
Okay, I'm going to do the same thing on the y-axis just to see what happens. Let's go up on...
Oh, yeah. That's definitely Z.
We're going to go up some.
Oh, boy. What happened?
I wonder if this switch is too close and isn't able to trigger.
So is Z actually Z?
Z is actually Z.
Okay.
Z is good. I had no question which one Z was.
Okay. Now let's try Y.
Yeah, I hit 100, which takes a while on Z.
Okay.
It's a more precise axis usually. So if you think about the way this is going to work, the screw has to turn more turns to go 1 millimeter than the belt has to ride. I hit stop, but it's not. It's too late.
Responding?
Yeah. Well, I can emergency stop. I should look and see what that command is.
I feel like that would be useful.
Would have been a minute ago.
Okay.
There we go. There's 100. Okay, so now I'm going to bring the y-axis back, and we're going to see what happens. Okay, so now I think it thinks...
Oh, that looks like that should be...
That's the x-axis.
Yep, that's X for
but
sure.
it thinks... Let's see.
That's Y. That's good.
It's stopped there.
Okay, is that the most it can go out? Is it hitting anything? It should hit at...
Yeah, it's not hitting that switch.
Where's the switch?
It's in here. Like this switch isn't hitting. Right here.
Okay. Depress it again?
Hold on. Do we put this in backwards?
No, switch is in the right place. Oh, jeez.
It's okay.
Nope, not hitting the switch. Oh, I know what the problem is.
Is it that's
zip
too
tie.
far out?
No, it's a zip tie. It's this zip tie right here.
It's too far.
No, this zip tie.
How is this loose? Oh, it's slipping.
Yeah, it's this zip tie. This zip tie. It's not that zip tie.
This one's slipping too.
No. It's this zip tie right here.
I understand what you're saying. I agree. But this one's slipping too. Like this isn't in teeth, and it definitely was a minute ago.
I think it's because it was dragging.
You think it was skating?
Yeah.
Okay, well, let's...
So.
Hold on.
Oh, boy.
Oh, fuck. Okay, turn off the power, please. Oh, let me disconnect first. Okay, so now we got to take this one off.
I know. So this one Or it could be, yeah, you need to take it off.
No, it has to be taken off.
Yeah, and it needs to be slotted in there if possible, in that hole.
What do you mean?
Because it can't push out, because it's blocking the Delrin, because it's hitting the metal. So it needs to be in that hole.
How is that even possible?
Very good question.
I think we can rotate it so it's up instead of out. Because the problem is it needs to be on the top, not on the side. I don't know how I'm going to cut this one, though. This is where written instructions would be really handy.
I'm going to loosen. Does it need to be loosened here?
I don't think so.
Okay.
I mean, that might make it easier.
Oh, boy.
I apologize.
Surgery.
Let's see if I can just get this right here.
I learned my lesson. I'm not going to look at it.
These scissors aren't great. That was something. Fucking hell. This is where the clarification instructions are super useful.
Taking apart zip ties. Taking apart zip ties.
Really
there it goes. There we go.
Really wish I had a wire snip for this. Okay, so you know what? We should loosen this one so we have as much slack as possible on this side.
I'm gonna find the driver. You can just use your finger,
dude. It's loose. There, done. Okay, so let's think about how this is gonna work. I'm gonna rotate around so people can see a little bit. Poor Joey.
So right now, this needs to be tied to that.
Yeah. Let's loop this around here.
And the zip tie that
start to cinch.
I don't think you can put it on top because it's not going to lock.
Yeah, it'll be square. It'll go like right there.
Okay. All right.
I mean, I think. I don't know. I think you're going to have to do the zipping, and I'm going to have to squeeze again.
Okay.
You know what? Let's take this all the way off on this side.
I got that.
Okay.
Okay, completely off. Which gives you as much slack as you need, which is good.
Okay, so I think pull from right there, and I'll hold it in place right up against the wall.
Okay, pull.
You're pulling. Okay, how are we doing here? Let's see. Are we still cinched? Yeah. Okay, so give it one more. Yeah. I think that's probably pretty good.
That's good? Okay.
Okay, so I'm going to snip.
Okay, let's see if we can shove this in that.
I don't think it's going to shove in, dude. Wow. Oh no, I just turned off my laptop.
Oh, you know what? It'll be fine if it's on this side.
That's what I'm saying. It's just blocking the other side.
It's metal part.
It's not really, like, yeah. I like these tensioners, but I don't like everything else about this.
All right.
Also, they don't really tell you how tight the belts should be.
Nope. That's a difficult thing to relay.
They'll be calibrated from the factory. Oops. Okay, it's also possible, I'm going to look at this from the top, it's also possible that our gear is sliding off as it moves.
Is it hitting that?
That'll hit the switch, I think, now.
Okay.
If it doesn't, we got a big problem because it's going to take a long time to break that whole thing down.
Oh boy.
And move that switch forward 2 microns. Okay.
Power?
Power. I'm going to move this, I'm going to twist this zip tie around while we're here. I bet we're going to have the same problem on the x-axis. Are you powered up?
I'm powered up.
Last updated printer firmware SD and it fail. Okay, great. Okay, homing X.
Oh boy. Nope.
Power.
Nope.
Stop.
Power.
Unplug the power.
Oh, Jesus
I forgot to switch the remember when we switched the norm? It's okay. It's okay.
Adventures in 3D printing.
Yeah, that's the kind of noise that it makes occasionally if the end stops. If you remember, I don't think the first MakerBot even had end stop switches.
Nope.
I think it just you set it at 0, and it knew not to go past a certain point, which was great until belts started slipping, and then bad things happened.
Oh my God!
That was a
stop crying! Stop crying!
Yeah, we called it the MakerBot Scream in the old office. Okay.
All right, power back on.
Power back up.
All right. Let's try small increments of moving, X and Y. Jesus Christ. Which one is that? 100
Minus 100.
For what? Oh, well, okay. X is moving.
Okay, that's the wrong way that we needed to go hit the... Isn't the button on the other side? Why is it stopping? Huh.
Is it only moving in one direction?
No, it's
Oh, that's...
you know what it was? It thought that it was homed, and it wasn't. Okay, so that one hit, I heard that one hit the switch.
Yep, that's good.
Let's try the same thing with Y.
Okay.
Let's get crazy.
Yep, that's good.
That's better. Okay.
Awesome.
Feeling good about that. Let's see, where are we next? Heat on, home. Oh, I didn't turn heat on.
Wait, heat on already?
It said turn heat on.
Oh, okay, let me pull up those
heat on, home on, heat on. Home X, home Y.
Stop motor in that order.
Heat on and stop motor. Okay. So
wow, this is like the...
Let's restart. Okay. Let's do this whole thing from the beginning.
Okay.
I'm gonna move my X, move my Y. Oops. I feel like X and Y might be backwards. Give me an unplug and give me a replug, and we're gonna go through the whole thing.
All right, unplug.
Because I was hitting heat on for the heated bed, which we don't have. Now plug it back in.
Now power is in. Okay.
Okay, so now we're pressing connect.
Okay.
I'm hitting heat on. I'm home X or home Y first?
Home X.
Home X. That looks good.
Home Y.
Home Y. Also
now
looks
it says
much better.
Heat on.
Heat on again. So that turns off the heat.
And stop motor.
Stop motor. Okay.
Okay. Monitor the temperature of your hot end extruder by selecting the temperature curve view.
Temperature curve view. Oh, you guys can't see that right now.
There you go. Okay.
Okay. Joey moved it back over. Okay. So the purple line must be the setting, and the red line must be what our actual temperature is.
So the purple line, your target right now is 200 degrees Celsius.
That's my assumption.
That's right there. You see extruder 1, temperature 200, and you can change it right there.
Yep.
That's good. You want 200 between 200 and 210.
Heating up nice and quick. That's good.
That's good. That's good.
What's next?
We're on step 4 after that.
That's pretty exciting.
While your hot end is coming to temp, open your slicer settings. This is a slicer with a 3.
Yeah.
Go to the slicer tab and click configure.
Configure. Okay.
Okay.
I clicked it. There it goes. Something's happening.
Under the printer settings tab.
Printer settings tab. Okay.
Select custom G-code.
Custom G-code.
Remove any existing G-code in text.
From everything or just
in the start G-code field.
Done.
And enter the following.
I'm going to copy and paste. It's this G20X.
Mm-hmm. Yep.
Zoyo.
Mm-hmm. And I bet, yep. And you need ones, I don't know.
Yeah, spaces.
Oh, it's Y0.
I got it. Oop, did it again.
And then 0,
I'm going to type this in.
G29, okay. That's good. No, that's
Is
good.
there supposed to be a comma?
Nope. No. That's good.
Click the disk icon to save.
Disk icon to save.
You know what I hate? Disk icons. This is a Printrbot Simple.
Okay, good.
Okay, that's it?
Once the hot end is at temp, insert the filament. So I'm going to, at this point, open our filament bag.
Sweet. So we have a bunch of filament, but this came with a little bit of filament.
I need some
scissors. Exacto? Here you go. One thing that this printer doesn't have is a spindle. For the,
Could we print a spindle?
I would think we could probably print some sort of solution. I'm thinking what I might do is actually just build a thing that hangs off the bottom of the MakerBot table that has all the different spindles on it, so it's easy to feed it on, regardless of what printer we're using.
Huzzah! Wow, this feels like some cheap filament. It's really brittle.
It's PLA. That's the way PLA always feels. You're used to ABS, dude.
Which is nice and soft and shiny and.
Okay, once the hot end is at temperature, insert the filament. I'm going to close the slice through settings. Oops. We are at temperature.
Wow, that's fast.
Well, the hot end is always fast to heat up these days. The thing that's slow, that's a twist tie. Just untwist it.
It's not a twist tie.
Oh, it's a zip tie? We'll cut off the chunk.
Bam.
Did you just look away?
Yes. I didn't want to hit me in the face again.
Shameful.
All right,
okay.
Filament.
Oh, this is funny feeling filament. You're right. It feels dry.
It feels old.
No, it feels, usually filament feels a little wet. And this feels kind of dry. Okay.
Oh boy.
This is how you get filament cobbled. Okay, so there's my, I can't find the end. It's just, I feel like the ape at the start of 2001. Okay, here we go.
Wah, 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 wah.
Boom, boom.
The hole right there?
That is indeed the hole right there.
Compress the extruder spring. Ah, good. So you're just pressing that down?
That's my intention.
Yep, there you go. Guide the filament on top of the extruder, past the drive gear, and down the guide into the hot end.
I got to go in the hole.
Yes, push the filament into the hole. And then be sure the filament sits in the teeth of the drive gear and it's feeding straight into the hot end. Be careful, hot end will be hot.
Yo, dog, I heard you like ends that are hot. I smell
oh my God.
Lightly burning stuff.
Well, it says step 6, manually feed the filament through the hot end by compressing the extruder spring and
you mean like this?
Pushing the filament down.
Oh yeah.
So it should feel mushy, and it should feed through the hot end. So we should, oh, there it goes. Oh, there it goes. Ew, it's pooping. It's pooping.
Plastic. Hey guys, I'm a 3D printer.
You're a 3D printer.
Okay, so how much of that do I have to do, or are we good?
No, it's good. It's good.
Okay.
Turn the threaded Z-rod axis counterclockwise to touch the hot end onto the bed.
Turn the threaded Z-rod. Okay, so let's get the.
Okay. So you're manually turning this a long distance.
Yeah, that's right. Boy. Screw Norm, screw! So when we press stop motors, one of the things about stepper motors is as long as there's power applied, they'll hold position. Mm-hmm. Some of the early printers, it was a bit of a challenge to get to a point where you could hold position without the motors overheating, because they do tend to get warm when you're doing this. And a lot of the newer printers have fans that are actually on the motors to help control this sort of thing. This one doesn't.
The plastic spacer should fit snug under the auto leveling probe.
The Delrin spacer.
Here it goes.
Yeah.
It's going to be right there, or thereabouts.
You're going to take over?
Yes.
It goes faster when you use the smaller. Requires a little more finger strength, though.
More torque, fewer turns.
Yep. Can you take the, let's swipe off. So one of the things you want to be careful with when you're doing 3D printing stuff is touching the hot end, because it's 200 degrees Celsius, which is instant burn hot.
Balls hot.
It's hotter than balls. Balls are 37 Celsius. So it's at least 5 times hotter than balls.
5 balls hot?
5 balls hot. That's
okay,
real hot.
Whoa,
no, there's plenty of room.
Okay. Oh, you're about to hit it.
Okay, so now we need to adjust.
Lower this.
I think we need to adjust the print, the thing.
Okay.
Hold on.
Direction.
Let's see what it says.
These.
Turn the threaded Z-rod, blah, 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 blah. Turn both nuts. You want to put both of them on there.
I'm loosening the top one first and using the bottom one as the guide. And then tightening the top
I think you can
down.
do both at the same time, because they'll just ride. So see, put one wrench on the bottom, and we want to go that way, right?
No, other way.
Yeah. No, that way is going to push it up, because it's getting tighter. We want, oh no, you're right, we want to go down. Okay, so put your wrench on the bottom one, at the same spot.
Right there.
Okay, there we go.
That's not going to help.
Yeah.
If they had 3D printed a wrench that's the right distance.
God, that would be amazing.
And so it's the double wrench, but locked in the same height and vertical distance, so you slot it in.
That would be so good.
I mean, it would be simple to do with the notch.
This sucks ass.
This sucks. I think you loosen the top first.
I really wish that
use the bottom one to push.
Hey, Norm, that hot end,
is
real
pretty
hot. Yeah.
Did you touch it?
It's the McDLT of 3D printer parts. Okay, I think a little bit more. Is the light on the top of that thing?
No, yep, light's on.
So go ahead and cinch that down. Does the Delrin come out? Yeah.
No, this way. Okay.
Your wood wrenching is terrible.
This is a terrible wrench.
Don't blame the tools, Norm. Okay. Oh, here. Good grief.
Okay, you need to tighten the bottom as I...
Oh, is it turning? I don't think it can. Oh, we just lost the light. The light went off. No, it's okay.
I think I lifted it up too much.
Okay, so then let's bring the bottom one up.
We want the light to be on?
I think we want the light to be on. That's what the video said. I watched a 15-minute video about this process. I think we want the light to be on when the tip is pressing.
Light is on.
Is the light off now?
Light is off.
Is the light on?
Nope.
Is the light on?
Nope.
Is the light on?
Nope.
Is the light on?
Nope. Lower.
Hold on. I think I just cut a divot in the tape.
Jesus Christ.
Might need to go a little higher. Could have just caught on fire. Hold on, don't adjust it yet. Let's see what it's supposed to do.
Does smell like Bernie.
The plastic facer, blah, 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 blah. I think that I felt like that was pretty snug. Do you feel like it's snug? Where's to touch the hot end tip on the bed? It's much harder than it sounds.
The light isn't on is a problem. Oh, there it goes, light's on.
Okay, off. So it's touching right now. Is it on?
Nope.
Is it on?
Well, I also had the spacer there.
That's fine. The spacer won't matter.
Nope.
Still on? Yep. Okay. Tell me when it goes off.
On, off.
Okay. Let's see what is it on?
Off.
Is it on?
Nope. On.
Okay, so let's.
It's worse than finding studs.
I want to see if that scratches.
Oh.
I left a little bit of a divot. That's mostly plastic, I think. I think we're probably good.
Yeah, okay.
I think let's try that.
All right.
So now I go to the Repetier print panel.
Okay.
And I
send this following command.
Yeah, I have it. Repetier print panel. Okay. G-code.
Yep.
I assume G-code is. Oh no, print panel.
Mm-hmm. In that field.
Send G-code command. Yep. Okay, got it. And it's 212.
M212.
Yeah, space X0, space Y0, space Z0.
Yes.
Okay. So now we should have Z home.
Okay.
As well as X and Y.
Woo.
Oh wait, except for I moved a bunch of shit. Oh, let's home. Oops. Let's go up 10.
We don't want to fuck with Z anymore.
No, Z is locked.
Z is locked, but we need to calibrate
we need
X and Y
to
again.
home X and Y.
Home. There it goes.
Go to your home. Oh, that's probably actually is homed. Okay, so now down 10.
Mm-hmm. Just 10.
Tell me what I just printed 10. Tell me when the red light comes on.
Light's on.
Okay, perfect. We are going to set home.
Set that command again. M212. Yep.
Yep. Send. Okay. So now that's telling the printer, hey, this is your zero. This is the 0 point on all of your axes.
M500.
M5. Oh, capital M 500. Okay. Enter.
To save. Yes.
Okay.
Send. And M501 will check your work. I know.
M50.
Don't know. Capital.
So this is G-code. So this says these are all your settings.
Okay.
Yeah. Okay. What else we got? What's
next step? Load the G-code. Click load G-code.
Click load G-code. I don't. Oh, load G-code. Okay.
You gotta load the code. You can use whatever you want to print. You want to
I don't have any G-code. Is there something in this?
There's a link that says you can download a simple fan shroud.
Oh, that's good.
It's there's a link on the step 9. There you go.
Okay.
And this is it. This will be our first print after. Wow. Oh, we have to watch this in time lapse?
Are we going to have to sit here and move very quickly while the print goes very slowly? Simple fan shroud G-code. Okay, let's do that. Hopefully this works.
All right, so the code is like the actual line-by-line instructions.
Yeah, so as a general rule, I don't like doing
straight
G-code. I like to take a model, slice it, and then run the G-code from there, so that anything that's weird about my printer gets adapted for the printer. What do I do to make it go? Run.
Load G-code. Run the job. Click the play button to run the job.
Well, okay.
Here we go. Oh my goodness. It sounds like a 3D printer.
So the first time we printed something with the first MakerBot,
what's it doing?
I think it's leveling the build platform. I think it's confirming that the Z-axis
lights on, lights
is good.
Okay.
It says there's a 10-minute, the ETA on this job is 10 minutes.
That's not bad.
It's heating up.
Oh, that's fantastic.
There we go.
There it goes. Oh, it's printing. Oh, it's definitely printing.
Is it sticking?
Yeah, it's sticking around.
Oh, that's good. So I guess that this stuff has to, that thing has to not touch so that it doesn't whack into the model.
And it's doing these 4 corners, which is, oh boy.
This slicer on most of these prints, it has a different sound than our printer.
Could also, that's most likely the rods and the motors.
Well, no, that's the stepper sound.
But
one of the things that's neat about 3D printers is every slicer, even when you use a different slicer on on the same printer, they all make a slightly different music. So I think
you could be a 3D printer whisperer.
I talked to the Architect guys because they make music out of Tesla coils, and they have a history of building musical instruments out of things that are not traditionally musical instruments. So I said they should be using 3D printers to make music, but I don't think
they need pretty big 3D printers.
I don't think they're cool enough when you're used to working with lightning, harnessing the power of lightning. I feel like this needs to be a little bit lower, but we're in a good starting spot.
Yeah, this is better than the first try with the MakerBot.
With the cupcake for sure.
This might actually print, and I like the time estimate it gave you.
I don't know that the fan is actually working though, or maybe the fan only comes on at certain temperatures.
You see it not spinning? Oh, there it goes.
I just turned it on.
Oh, you just turned it on? Okay.
Manually.
All right. Well, that's good. You should. Is the point to have the fan on at all times?
I don't know. One of the neat things about PLA is it because it cools faster and is more stable as a. This is really an ugly first layer. It's more stable as it cools, like it doesn't shrink too much. Is you can make much steeper overhangs with PLA than you can with ABS.
Don't be so judgmental about the 3D printer.
Well, it's kind of fuggo.
Did you you didn't set the micron thickness because that was all in the G-code.
That's already done.
Yeah, pre-done in the G-code.
So who knows? Who knows what's going to happen here? This could be for a lower resolution printer or all sorts of stuff.
But we're right now printing, no mystery, a fan shroud for the Printrbot, for that fan. This is pretty impressive so far.
Just from an up and running standpoint, it is a dramatic improvement over even the Thingamatic, which is the last kit that MakerBot built. We haven't, like I said, we don't have a ton of experience with like the modern 2014 state-of-the-art kits.
Alternative,
but this is promising.
This is very promising.
And if you get something that's even close to usable on your first print, I consider that a moral victory, if nothing else. Now, step 10 is don't be concerned if your first attempt goes poorly. It'll likely be stringy, which means that the negative Z value is probably too high. And then it gives you the commands to lower the Z axis just a little bit more each time.
That's for amateurs as well.
What do you want me to do?
We're not amateurs. Look how well this is turning out already.
Well, I know, but they want to make you feel good in case it doesn't work.
6 by 6 by 6.
Yes.
That's not bad. What are things that you can build a small portal cube?
You can build a bunch of stuff. I mean, if you want to build small mechanical stuff, this is a perfect size for it. And PLA is more than acceptable.
So this came with this amount of PLA?
Yeah. What did it say on the bag? Is it a ½ kilogram?
It does not say on the bag.
It's probably a quarter of a kilogram. But you can get, now you can even get PLA at Amazon. So you can get 1.75 millimeter diameter PLA, which is what this is, at Amazon for anywhere from 25 to 50 bucks a spool. MakerBot sells really expensive PLA, but they tend to have better quality control in my experience. I've experimented with some off-brand PLA and ABS and have had real up and down experiences with it.
Now, the demo we showed just ran G-code. What is the process if we want to switch back to that software for loading STL files?
So Slicer, we set up that SLIC3R is a third-party slicing engine. It was one of the first that was very fast, and you can go in here and basically open up an STL file and then run it through Slicer to generate the G-code that you then send over to the printer. Now the next thing I think I'm going to do with this once we get it up and running is I have a Raspberry Pi sitting unused at home that was originally a media center and didn't really have the juice to do that. But there's a great piece of software called Octoprint, or Octopi, I guess, that is essentially a print server / webcam runner / web server that lets you make a simple 3D printer that runs open firmware into a network-controlled 3D printer. Now you won't be able to dump stuff off of the end of the platform. Right. Somebody has to still do that manually. But you can at least look at the print and see how it's doing from somewhere that's not in front of the printer. And even send print jobs to it, like if I wanted to start something before we're in the office or something.
So you're talking about sending commands. You can set up a webcam, and you can actually set up commands to adjust level, reposition,
and print. You can send. I think you have to send G-code in that case, but you can dump a G-code file across the internet to the printer, and it'll start printing, and it'll watch the webcam and tell you when it's done. Send you pictures along the way. Send you a time lapse even. Wow. If only we had a thing on the website where we shared time lapses of 3D prints happening.
Oh my goodness.
So yeah, that's real stringy. We need to lower the Z-axis a little bit. That is what's happening here. I don't know what resolution this print is either.
It looks pretty fat.
Yeah, resolution. It might be a 0.2 millimeter.
Those holes are not very good. The holes where it's supposed to mount to the
Well, they don't have to be great. They just have to be something that the screw can bite into. And it may be that turning on the fan was a mistake. I don't know. What do you say we let this finish in time lapse and come back in a minute or two when it's done?
All right.
It looks like
how many minutes
we have left? 7 minutes and 51 seconds.
Wow. Let it roll.
Do you want to talk about Orange is the New Black?
It's a great show.
It's really good.
I've not finished season 2 yet.
Neither have I. I think we're in about the same place.
I'm episode 8.
I don't know. Did you get to the second whole episode yet?
Second.
You know, where he discovers. Yeah.
Past that?
Okay. I think that's the last one. I might have seen one past that.
I've seen probably 2 past
Red's beginning to plot her revenge.
Yes. Kate Mulgrew's
really good.
Comeback role.
Yeah. Does she need a comeback role? She's been in a lot of stuff over the years.
She has.
Yeah.
Let's let it run. I'm going to deem this a success.
You are so far ahead of yourself.
Print.
Wow, it's interesting. It actually lifts up and goes down. Even on the same layer, just to make sure that the nozzle's clear. So the tape around the nozzle also makes it hard to get the platform flat. The nice thing about this design is theoretically you shouldn't have to level the platform. It should be impossible for this platform to get out of level.
Because it's metal?
Because it's metal and it's mounted to the rods and everything should be level relative to each other.
But it's still, it still checks the corners.
What do you mean? I think that's always good to have confirmation, right? I mean, the bad thing about this design is if it got off level, I don't know how you would fix it.
Whoop. What happened?
I moved the cursor inside the window. Wow, that slows it down. That's super weird.
Oh boy.
We're printing layer 9 of 144 right now.
So is it sending the code in real time?
It is sending the code in real time.
Sounds like?
Yeah, there's no SD card in this that I'm aware of.
It's not, okay.
And
so if your computer crashes, the print will stop.
Yeah, but that's the way we've been using the MakerBot for the last 2 years anyway. The printing from SD card is one of those things that it's like the automated build platform where you had a conveyor belt that rolled the print off when it was done. Seems like a good idea.
No.
Terrible in practice.
Yeah. Automated build platform.
Yeah, the SD card thing, you would get like 2/3 of the way through a print, and if there was a big curve or something like that, that it needed commands faster than the SD card could read commands off, it would stall and the print would fail and it would be bad. You'd get basically no idea what was the problem, except it would fail in the exact same place again the next print. So yeah, I don't miss the SD card reader at all. Also, since they're all Linux-based and they only support FAT16, basically the only SD cards you can use are 1 gig SD cards, which now cost like $30 because no one has them. Yeah.
Found one in the cupcake.
I found one in the cupcake. I was super excited because it's one more SD card. We broke the safety, the anti-deletion lock off of one of them the other day by accident, and I've been trying to figure out how to rig up a replacement for a 1 gig, 5-year-old SD card. So, what do you think the future of 3D printing is, Norm? Do you think that people are going to put these in their houses?
Not this one for most people. Oh, whoa.
What's wrong?
going on? It's when oh no. I'm looking at the.
You're looking at the nozzle, the detector.
It's way more practical to have a small laser cutter.
I think so too. First order of business is building a spindle for this printer.
You can't wrap it around the top?
That seems like a terrible idea.
I think it'll be all right.
Their printer looks much better. Their nozzle looks much better than ours.
Their fan shroud?
Their fan shroud.
Don't be sad, Will. It just means that you need to adjust the Z-axis.
I do need to adjust the Z-axis. And then when we're done, I'm going to press, I did it, success.
Step 11.
That's step 11. I almost think we should stop this one and start it back up again.
You're calling it?
I'm not. I mean, it's only got 6 minutes left, so let me see if I can download an STL and slice it myself.
That might slow down the print.
It shouldn't. Loading a configuration file and printing an STL file on your Printrbot Simple. That's the next guide.
What's also interesting is that because the sensor is around the same height as the extruder, it is rubbing against the plastic as it dries and smearing it.
The sensor? It shouldn't.
Like that in the middle?
Yeah, it shouldn't. It should be above it. It's not the same height. It's off. Remember, it's the Delrin,
just a little bit.
Delrin piece thickness. I think the problem is that our first layer was too far off the print bed, so we're ending up a little smushier than we might like, or stringier than we might like. I'll upload this to that Flickr group when we're done.
It all hinges on that very first layer, because the first layer needs to be.
Yeah, if the first layer goes bad, then all bets are off.
And the reason is that the first layer needs to be adhered to the build platform pretty well, and needs to be squished, which means and so all the subsequent layers are then all pushed down and dried on top of that.
Typically, even the slicers will increase the feed rate, the amount of plastic that goes in, so more plastic comes out on those first few layers, just to make sure that you don't have that stringy problem that we saw early on with this. I think I've seen enough of this to know that it's not going to work for what we want. So I'm gonna cancel this one, and we're gonna make a slight adjustment, and we're gonna try again. And there's actually more slicer configuration to do in just a little bit.
Job killed.
Job killed.
Wah, wah. All right, let's evaluate. See what this print looks like.
Oh, we're back on. We're back on. Can I pry this off?
Pry duty. Hold on. Oh.
It's okay. I pried. That's pretty fuggo. I think we can do better, Norm.
Let's take a look.
While you do that, I'll set up the next print.
Here it goes. The very first 3D print from our office from a Printrbot Simple. You're right. It does look pretty fuggo.
Yeah, it's not good.
It's a little stringy here, a little stringy there. But the commands did work out. We will recalibrate more, and you might see the Printrbot make more appearances.
Oh, you think we shouldn't? I think we should start another one. Let's see how this goes.
We'll start another one and wrap it up because we're at an hour now.
Do you have someplace to be?
Yes.
Okay. Let me start the G-code then. Loading G-code. Where did I save the G-code?
Desktop.
Oh, simple fan shroud. Simple fan shroud G-code. Okay. Let's try it again.
Oh boy. Wait, did you make any difference?
Yeah, I changed the Z-axis 0.2 of a millimeter.
Oh boy. Oh, I'm gonna away. Wipe with some
That's an isopropyl wipe. That just gets the finger oil off, which means that stuff will stick a little bit better. Ironically, it also takes off the Scotch blue branding on the printer. So it's leveling, it's checking the level.
Checking the corners. That's pretty good. Oh, it's good. It's heating up now.
It should be heating up now, and it says 10 minutes, 16 seconds.
Okay. That dip in temperature.
That's when it turned off.
Are you going to turn the fan on or off?
I don't know. Turn it on. It's almost to temperature. Almost there. Oh, there we go. Fan's on.
Let's see.
Oh, that looks a little bit better.
Looks. Oh, okay. All right. Not bad. Not bad.
I don't know what those little divots are unless they're just pads to help the edges stick better.
That's a lovely song.
It is a good sound.
That looks pretty good.
That's a pretty good looking circle edge.
Kind of a circle.
I don't think it's supposed to be a circle. The neat thing about this software is you can actually see, if I can do it.
Now the adjustments you made to the Z-axis, you just did.
I did with G-code.
With G-code, you didn't manually level or anything. You saw that. You assume, based on your experience, that kind of messiness, this kind of stringiness.
Was looking at 0.2 of a tenth. I almost went with the tenth. The instructions recommended 2/10.
Compensated 2/10.
And I feel pretty good. I think maybe we could go even one notch further.
Yeah.
This is going to be really glued onto the paper, though. Sometimes with PLA, you'll get it'll get stuck onto the tape, and you end up with a little bit of tape on the bottom of your print, which is okay. Now, if you cut over here, you can see the print happening on the 3D view, and it's showing you where the print head moves with this software, which is really cool. I've not seen that before. And see, it's like circles are hard because it's a stepper motor. So in order to make a circle, it's kind of like an Etch-a-Sketch. So you turn the two knobs, and you have to do it at a very precise rate. And the accuracy of your steppers is what determines how good your circles are going to be.
Did we ever tighten the
X belt?
The belt on the X?
I did.
Okay.
Or the Y belt, you mean? I tightened the Y belt.
Underneath the build platform.
I tightened the X belt and the Y belt. The X belt I tightened while you were doing something else a while ago.
Okay. Well, it's working.
Yeah, I think it could still go a little bit lower, but this is probably okay. This could also just be a kind of crappy slice.
Yeah.
So it looks like on this picture, the white bars are the travel lines, the red bars are the current layer that's being filled, and the blue layer is the previous layer, the blue lines.
Computer numerical control.
Yep.
It's the future.
I don't know what that was.
Whoa, yeah, see? That's weird.
Well, that's putting the screw holes in, I think.
Stuff in the middle?
Yeah, it's not doing a good job on those circles. I kind of wonder if this one, letting this one slice itself might be better. Did it slip?
Ooh, whoa.
Oh, something slipped.
Yep. Abort.
Well, hold on, let's see what's caused the slip. It looks like a y-axis slip.
Yeah, everything's shifted up.
Yeah, so is this
the belt?
Is this motor turning? Let's see. Yep, Y belt is loose again.
Loose belts. Classic problem.
Yeah. Okay. Luckily,
you can tighten.
I think I can tighten this on the fly. This is probably not recommended. I'm sure somewhere on this site there's a video that explains the tensioning procedure for the belts. We didn't see it when we looked.
Yeah.
Oh, okay, so I'm going to kill this one, and then we start over again. Oh, okay.
You might have to reposition as well.
We'd have to rehome.
Rehome.
Oh, this is really glued on.
Spudge.
I think it probably homes on the initial.
Oh boy.
What's making that buzzing noise? Oh, that's the fan, isn't it? Yeah. Okay. So this is a lot of the glamour of 3D printing.
Prying plastic off tape.
Yeah, and the goal...
You know, worst case is we just peel off the tape. But oh, there it goes.
I got the tape too. Might be good enough that I can save it though. Where's my scraper? How cheap are you? Nope, new tape.
Yep.
Just one piece though.
Yep.
Behind the scenes on 3D printing, we have a 5:30 call, right?
Yep.
Okay.
Be very, very careful.
Is Elmer Fudd a protected group? He has a speech impediment.
I do not think so.
You took those classes, you should know. I learned about protected groups this morning. Okay.
All right. Smooth that out, squeegee that out.
Yep. Home X. Boom. Home Y. I'm gonna go and move it down. Oh, it's still slipping.
Oh, there you go.
Isn't it?
I'm gonna check.
Hold on.
It's pretty taut.
Yeah, but see, it slides. So watch. I don't know if you can see.
Which side is it sliding on?
It doesn't. It's the y-axis is sliding. I don't know which side. There's kind of. Yeah, see, it stopped there. I don't know why it would stop there unless. I hope we haven't messed up the belt. It's more or less the same spot every time, but the belt looks fine. I wonder if my gear is spinning.
Is it on the rod?
I'm gonna look and make sure that the nut is still in a good spot. That may be the problem on the lock nut. Yeah, that's the problem. Okay, so how am I going to fix this?
For the set screw?
Yeah, the set screw slipped.
Loctite.
Loctite would have been good in retrospect.
All right, that's not going to be a problem that's going to be solved.
Yeah, I'm done. It'll take like 2 minutes. If you want to wrap it, we can though.
We will debut this.
Maybe tomorrow?
Maybe later today.
What do you mean later? Oh, no, we aren't going to do it later today because we've already shot that. Okay, so. Now we're going to cinch this down. So what happened was the set screw slipped on the shaft, and somehow, I don't know how that happened, but we ended up with...
Do you need to tighten the set screw on any of these other axes?
Shouldn't. It's only this one that's slipping. The others were fine. I'm going to cinch this little bastard down real good, though. Okay. And now I've stuck that. There we go. Okay. Okay, let's see what happens when we move the y-axis. Go to your home, no slipping.
All the way, it's moving.
No slipping.
Oh,
Oop, too far.
Too far.
My bad.
That's pretty good.
I'm going to go to M5. Oh. Damn it. I just reset the home for the Z. Hellfire. Okay, so stop motors. Bring this down. I got to do all that stuff again.
Well, at least these two are calibrated.
Yeah. Okay. So tell me when the red light hits.
Yeah, that's a good way. Nope.
Or you could just turn it until the red light hits. That might be the easier way to do it.
Counterclockwise?
Yeah.
Oh, there it goes. Let's see, go up, 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 off.
I think you want it just on.
There it goes. It's on. It's on. I can also adjust it 0.1.
I'm going to adjust it 0.3, but I got to do the M500 and the M2112 stuff. Okay, that's done. Now it's M500 to save.
Mm-hmm.
M501 is to verify my work. And now I'm going to do the bed probe offset stuff. And I'm going to do this 0.3. So this is in millimeters, I assume.
Mm-hmm.
And now it's M500, M501.
Okay.
Bed probe offset. Okay, so the offset is 0.3. We should be, let's try it again.
Play. All right, check your corners.
Okay, it's heating up.
Okay.
It's
Still have some
heating up.
tiny set screws.
Yeah, the extra set screws were in the right angles. We shouldn't have needed those, I don't think.
I'm going to give those back to you.
Yeah, that's good. I'll put them all
Just
in a
in
box
case.
someplace. And then I'll go buy some Loctite. We're real close on the temperature. So the slicing is one of the things that takes a fair amount of time, although with Slicer it's much faster than like old Replicator G and stuff like that.
And depends on the complexity of the slice.
Yeah, the complexity of the model, the amount of overhangs, the number of holes, stuff like that all makes a difference. Okay, that looks good.
Okay. Just gonna do those four corners.
There's a circle there now, finally.
Oh wow, that's much better than before. Yeah.
Oh, that's a nice looking circle.
Wow.
Okay.
Oh, that looks good.
So after this print finishes, I've got to set the default settings for Slicer, which tells the slicing engine what this machine's capable of, how big the print bed and all that stuff is, and then we can go.
You can actually process
and
STL
put
files.
STL files and do things like print and make a mystery object, which I guess is no longer called the MakerBot mystery object, and we will just call print a mystery object.
Print some mystery object.
Yes.
We have battling 3D printers.
I'm super interested to see how this compares to the MakerBot. Because, I mean, the MakerBot, the Replicator one that we have was a $2,000 and change printer. This is a $550 printer. It's much closer in price to the original Cupcake. But already I'm kind of impressed with the capabilities.
Oh, yeah.
I'm going to turn that fan on.
Although you have it printed in PLA. You're printing in ABS.
I print PLA some. Like if you look at the stuff that we've printed, the things that are that kind of lemony yellow, this color, are PLA. The clear blue stuff is PLA. I prefer the ABS. I think the ABS is a little bit easier to work with, and seems to be a little more predictable with the extruder that's on the Replicator one.
That looks pretty good.
This is looking a lot better. So this was a 0.3 millimeter offset from what we initially set. And now we could tweak this and dial this in so it's perfect with the sensor in the right place. But I'm actually okay with doing it in software. It seems a lot easier than using your dual wooden wrenches. It's saying there's 9 minutes and 20 seconds left. So.
Let's watch this finish, and then you'll have an accessory for your fan.
Yeah, we'll put the fan shroud on. It's exciting. And I think what that'll do is blow straight down onto the nozzle.
$550 is still a lot of money, I think, unless you actually have something to do with a 3D printer.
I mean, it's less than a laptop. It's less than a decent laptop.
Sure.
Like once you get in that territory, kind of like it's.
And most people buy laptops or game consoles knowing what they're going to do with them.
Yeah.
If this is still not something to buy to then figure out what you're going to do with the 3D printer.
No. And it's also not the kind of printer you're going to use to mass produce something. So if you think...
No. I wouldn't use any of these printers to mass produce.
Like
make a replicator even? No.
If you want to make something that's custom but mass producible, like say you're an Etsy maker and you want to have something that you can put somebody's name on and then paint and finish and make it look nice, this is not a bad way to do that depending on how much volume you're going to do. I really look at especially the $500 printers though and think this is the kind of thing that if I had a 10-year-old kid with a lot of free time, an interest in 3D modeling or design or whatever, this is a can't miss for that. If you can spend $500, get them a copy of 123D Sketch, which is free, and
all the
software that comes with this is free. That you need to run this is free. So then you can go from you basically turn bits into atoms, which is the super interesting way to. Like once you have that ability, it opens a lot of doors, and it makes learning 3D modeling a lot easier. I think when you have. When you can do something, iterate, then print it, see if it worked or not, and then go back and do it again. And the PLA is made from cornstarch.
Yes.
So it's a completely non-toxic. There's no noxious fumes. You don't have to worry about ventilation. You can inhale it according to the material safety sheet all you want, and there's no risk of bad stuff. ABS is also very safe. It's what a lot of food-safe plastics are made out of. But it does smell bad when you're printing. And at least the first couple of years, I kind of consistently had a headache until we moved into a better ventilated part of the office.
Can you download things from Thingiverse and process it through Splicer to print here?
Once we have Slicer set up for this printer, you should be able to download any STL file, which is what everything on Thingiverse is saved in, and print it on this, assuming you can size it for the print bed of this printer. It's a little bit smaller than the Replicator 2, but those files are in many cases Creative Commons and are available for everybody to use.
Is there software to resize?
I haven't used this enough to know if you can actually resize stuff in this 3D view. It kind of looks like you can. But like I said, I haven't tried it yet to see. It's relatively simple to resize stuff using, say, Blender or something like that, which is another free CAD software. And yeah, it looks like you can scale stuff. It's not as simple as it is with Makerware, but once you kind of get the knack. The way to figure out how this stuff works is to get something that's a fixed size, like a 20-centimeter calibration cube, print it, scale it up, print it, see what happens, scale it up, print it. It's where your $20 calipers come in really handy. I'm really pleased with how this is looking so far. This looks pretty good.
Yeah, much better than the one before. God, this brings back memories.
Never forget, Norm. So, do you remember when we printed the first cupcake and it took the better part of a week because we kept either breaking stuff or not having the right tools and having to go get them. And then on Friday afternoon at probably 4 o'clock, it printed, but nothing stuck together because we had the calibration wrong. So we ended up printing like essentially, I call them MakerBot pubes. But it's just a thin spaghetti. Yeah. I was really pleased. I've never been as excited to see the printer make something come out as I was on that. So we went to the bar afterwards with everybody at work and showed our spaghetti, and no one was impressed.
No one was impressed. No. I would be impressed with this, though.
This is pretty good. This is a usable part. It looks like it'll be airtight, which is important for a fan shroud. The holes for the screws are going to be tight enough that the screws will actually bind in them.
God, you could tell the difference. Where at this point we're about the same, maybe a little further along.
This is about it. It's about 7 minutes,
and it's just that much more compressed on the build platform right now because everything's sticking to each other better, and it's not inflated.
It's all literally without the right beginning, the 3D print is going to be bad. And it's the difference between 0.3 of a millimeter and 300 microns of vertical calibration made the difference. Okay, so while this is printing, let's talk about building a pre-assembled kit versus making your own.
Sure.
I mean, we built a couple of printers. We bought a couple of printers and used them out of the box. Mm-hmm. I feel like after building 3 printers now, the build process is really instructive when you're learning how to do this, because it makes you understand how the whole thing goes together.
Yes. And just because you get it pre-assembled doesn't mean it's exactly going to work out of the box.
Yeah.
And if it's your first 3D printer, you're not exactly going to know.
Just to be clear, it should work out of the box.
It should, but
we've had real mixed results with that.
With big companies, maybe not so much. And from what we've heard of other people who've bought pre-assembled 3D printers, they've had to maybe send them back completely or disassemble them. Building it yourself, especially something relatively as simple as this, with better instructions, you learn a lot more.
Yeah, I mean, just the mere understanding of how the hot end works and how the extruder feeds plastic through.
Or where the points of error are.
Yeah, it helps you. Now, the downside of building your own printer is generally the troubleshooting information is pretty thin. Like I was able to troubleshoot that y-axis problem just based on lots of experience. I was able to watch the motor shaft turn in the motor and see, okay, the motor's turning, but the belt's not moving. The belt seems the right tightness. What's the next point of failure? Did our set screw slip? And it did. Like that stuff you learn the hard way, and you may not get the support you need. You're probably going to be in a figure it out yourself mode, rather than calling an 800 number and having somebody come to the house or handhold you through fixing that process. So if you're not a basic level of mechanically inclined, if you don't take things apart and fix them yourself, maybe the DIY kit, the ready to print kit is the way to go.
But you don't even need to know that much electronics. Like the board,
there's no soldering.
There's no soldering. You don't need to know about voltages or anything. You just need to know about the headers.
You need to decode the instructions. If you can look at those instructions and figure out more or less what's going on, you'll be okay. And there are, of course, other printers that have printer kits that have easier instructions. I know if you go to Make Magazine's website, they have a whole list of their favorite printers, including kits with especially good instructions. So you can find that stuff out there. There's also a lot of videos that we didn't, in fairness, look at for this, so they may have covered all the stuff that we had problems with in video. But obviously, for this kind of video on our end, watching the video in advance and then trying to use that to decode the instructions wasn't really practical.
All right, how are we coming along?
We are at, and it's also worth mentioning, this kit assembled was $600. It was $540 unassembled.
So it's about 60 bucks.
60 bucks difference. I think that's a very fair $60. We are 6 minutes and 1 second out, according to Repetier. It's going to start doing a circle in a sec.
Is there another circle?
Well, it makes a shroud, so it's got to come over the top of this thing to make like a duct, basically. We're on layer 12 of 144.
Wow.
I feel like maybe this time estimate isn't the most accurate.
No.
I'm going to set a timer for 5 minutes that I'm going to start when we reach 5 minutes on the countdown.
Okay, Google.
Hold on.
Okay, Google. Set a timer for 5 minutes.
And 41 seconds. Yeah, see, it's been at 5. It holds for a long time sometimes. It looks nice, though. So the other thing that the slicer does is it determines it treats, based on the printer that you're using, is it knows that outside walls need to be thicker, so it runs more plastic through or runs the print head at a slower speed. It knows that the bottom and top layers need to be thicker, so it does the same thing there. It also is even aware what the overhang capabilities of the printer are. So how much can one layer hang over another layer, that camera's not on so it's fine, before the plastic starts to sag or make a big spaghetti mess.
How much plastic do you think this is going to use?
Hardly any. This software will tell us at the end, I think. Or maybe that's an Octopi feature, I can't remember. something somewhere will tell us how much plastic we use. And the neat thing about 3D printers is the amount of plastics that's going to go in this thing is probably like a foot, maybe a foot and a half at the outside, because you are, cutting down 1.75 millimeter diameter plastic into 1/10 of a millimeter size hole, or maybe 2/10 of a millimeter size hole. And like if you look at this print, I don't know if you guys can see it, but the plastic looks a little bit shiny as it's coming out, which means you're doing things right. That's usually a good sign. Still not to 5 minutes yet. And I feel like it's been way more than 40 seconds.
Oh yeah, I got 3 minutes left on my timer.
Yeah. It's not so great at the ETA. I'm already at 4 minutes and 50 seconds, and it's at 4 minutes and 58 seconds. So
let's jump forward ahead.
Yeah, I think we're gonna high speed through this
and get one final wrap up when it's done.
I think that sounds like a good idea.
Speed it up, speed it up.
It's done!
Finally.
That was the longest 10 minutes of my life.
So, things we learned, the estimate,
the Repetier estimate is far, far from accurate. It said it was going to be 10 minutes. It's been like 55, I think, 50, something like that.
Yeah.
But
pop it off.
After,
that's okay.
Well,
that's all right.
We got plenty more painter's tape.
Yep.
The end result is really good. Here, I'll put it down here. Maybe Norm, you can. There you go, right there. Watch out, that hot end's still probably pretty hot. So I think this is going to go on underneath the fan between there, and the nozzle will point down
direct
right onto the freshly extruded plastic.
Let's look at this print.
Really pleasantly surprised by that. It's pretty good. The screw holes are there. Circles are hard. It did a good job on the circles. Holes are hard. It did a pretty good job on the holes. It looks like a 0.2 millimeter print.
It's definitely not the finest we've seen.
Can I see? Yeah, Yeah, I would think that that's a 0.2 millimeter. The top's a little bit rough. I don't know exactly what happened there. It looks
2
like,
microns.
Like it was maybe 200 microns.
200 microns.
It was a little bit wobbly at the top there. I'm going to set up the slicer and stuff like that. We're going to maybe try using this for print the mystery object in the future. I'm definitely going to set up Octoprint for this because Octopi for this. I'm super interested to see how that works. And I want to see if we can set this up so it'll run a little bit more remotely, and I can just feed G-code to it over the network. If we get that working and we get it going, then I'll do a blog post on the site as well as like a short 5-minute video so we can show kind of what you can do with it and how it works. For anybody out at home who may be interested in trying that with their own 3D printer.
But that is the Printrbot Simple. It's the first of our month of builds.
It's the July Buildopolis.
And which will bleed into August. So thank you for watching.
Hold on, do we want to tease what next week's build is?
That's not teasing. I think if you watch the videos from this week, there are many hints throughout this week that tell you what next week was. Come back Monday.
What tools can people expect to see us use next week?
We will use
cutting mat.
Cutting mat.
X-Acto knife?
No, that's too much. We've said too much already. Come back next Monday. Go check out Tested. Thank you, premium members, for backing this video. Let us know what type of videos you want to see, what projects you want to see us build, and
whether you like this. If you like this, if you don't like us, leave feedback. We definitely appreciate it on YouTube or on Tested.com.
Raw building.
If you want to find out how to be a Tested premium member, you can go to Tested.com/membership. And I guess we'll see you guys on Monday.
See you guys next week.
Have a good weekend.
Bye.